dusty archives of paleontology, some mysteries are whispered about in hushed tones. The kind of discovery that makes scientists question everything they thought they knew. In 1996, a single claw emerged from the ancient rocks of Patagonia. 30 centimeters of pure anatomical enigma that would become the scientific equivalent of a cold case file. This wasn't just a fossil. This was the beginning of a hunt that would take decades, challenge the brightest minds, and reveal a predator so unique, it would rewrite the rules of prehistoric evolution. Megaraptor's name is a classic example of paleontological misdirection. When its fossils were first discovered in 1996 from the Portezuelo Formation in Patagonia, Argentina, scientists initially believed they had unearthed a massive member of the dromaeosaurid family, the raptors popularized by Jurassic Park. This classification was based on limited fossil evidence, primarily a single enormous claw that appeared similar to the iconic killing claw found on Velociraptor and its relatives. The name Megaraptor Namenhuaiqui was assigned, combining the Greek for great thief with a term from the Mapuche language. This nomenclature conjured images of a gigantic raptor, perhaps 3 times larger than Deinonychus, roaming the late Cretaceous landscapes of South America. However, as more fossils were uncovered, the narrative surrounding Megaraptor began to shift dramatically. Paleontologists, including Fernando Novas, who first described the species in 1998, noticed peculiarities that didn't align with typical dromaeosaurid characteristics. The bones were more lightly constructed than expected for such a large predator, and the proportions differed from those of a typical raptor. The most significant revelation came with the discovery of more complete forelimb fossils. The massive claw that had initially defined Megaraptor as a giant raptor was actually located on its hand, not its foot. This discovery fundamentally altered the understanding of Megaraptor's classification and anatomy. Further studies revealed additional unique features, including elongated vertebrae and pneumatic bones filled with air sacs similar to those in birds. These anatomical characteristics puzzled researchers, as they didn't neatly fit into any known category of theropod dinosaurs. As more fossils were analyzed, a new understanding of Megaraptor emerged. It wasn't a raptor at all, but rather a member of a previously unknown lineage of theropods. This group, later named Megaraptora, shared some features with allosauroids and carcharodontosaurids, while remaining distinct enough to warrant its own classification. The reclassification of Megaraptor exemplifies the dynamic nature of paleontology, highlighting how initial assumptions based on limited evidence can be misleading, and how new data can reshape our understanding of prehistoric life. This case study demonstrates the importance of continuous research and the willingness to revise theories as new evidence comes to light. Megaraptor's unique anatomy set it apart from other theropods of the late Cretaceous period. Its hand structure proved to be particularly fascinating, characterized by elongated fingers, with the first 2 being notably large and slender. The third finger, in contrast, was significantly smaller. This distinctive anatomical feature bears a resemblance to the hand structure of some basal coelurosaurs, hinting at Megaraptor's complex evolutionary history. The massive 30-centimeter claw, now correctly identified as part of the hand, was more than just an impressive weapon. Closer examination revealed these weren't typical theropod claws. They were specialized tools perfectly adapted for Megaraptor's predatory lifestyle. The claws were sickle-shaped and more recurved than those of Spinosaurids, suggesting they were ideally suited for gripping and tearing prey. This level of specialization points to a highly refined hunting strategy, setting Megaraptor apart from its contemporaries. The robust nature of Megaraptor's forelimbs provides further insight into its predatory capabilities. These were powerful, well-developed limbs powered by strong pectoral muscles. Such muscular development would have allowed for complex movements, significantly enhancing Megaraptor's ability to capture and manipulate prey. This adaptation stands in stark contrast to the trend of reduced forelimbs seen in many other large theropods of the time. As we piece together Megaraptor's unique anatomy, a picture emerges of a highly specialized predator, unlike anything in today's ecosystems. Its combination of massive hand claws, elongated fingers, and powerful forelimbs suggests a hunting strategy that was both effective and distinctive. Megaraptor was a precision killer, equipped with tools perfectly adapted for grasping and subduing its prey. The detailed study of Megaraptor's skeletal features does more than refine its classification. It opens a window into the diverse and specialized world of late Cretaceous predators. As we continue to unravel the mysteries of Megaraptor's unique adaptations, we gain valuable insights into the complex ecosystems of Patagonia 84 million years ago, where this enigmatic hunter played a crucial role. The ongoing research into Megaraptor's anatomy continues to reshape our understanding of theropod diversity and evolution during this fascinating period of Earth's history. The late Cretaceous ecosystem of Patagonia, preserved in the Portezuelo Formation, presents a complex tapestry of life from approximately 90 to 85 million years ago. This coastal environment, characterized by warm, humid conditions, supported a diverse array of flora and fauna. Dense forests and open plains provided resources for a wide variety of creatures, from insects to massive dinosaurs. At the foundation of this ecosystem was an impressive variety of plant life, evidenced by diverse fossil remains. These plants supported a multitude of herbivorous species, which in turn sustained various predators. Among the most striking inhabitants were the titanosaurian sauropods, including species like Futalogonchosaurus, Balsaurus, and Melargosaurus. These colossal plant eaters, some potentially reaching lengths over 30 meters, would have moved in herds through the Cretaceous landscape. The Portezuelo Formation also hosted a diverse array of theropod dinosaurs. Alongside Megaraptor, smaller dromaeosaurids like Nuconraptor and Unanlagia were swift, agile hunters. The presence of Pamparaptor suggests multiple predatory niches within the ecosystem. Another notable theropod was the Alvarezsaurid Patagonicus, a small, bird-like dinosaur with specialized forelimbs possibly adapted for insect foraging. Abelisaurids, represented by species like Alemgosem, further diversified the carnivorous fauna. These distinctive theropods, with their short, deep skulls and reduced forelimbs, occupied a different predatory niche than Megaraptor. This variety of carnivorous dinosaurs indicates a complex predator-prey dynamic within the ecosystem. The fossil record also reveals a rich aquatic component. Fish species like Lufwichthys inhabited ancient waterways, while turtles such as Portezuelomis lived in coastal areas. This aquatic life provided additional food sources for terrestrial predators. In this ecologically diverse world, Megaraptor stood out as a unique and formidable predator. Its specialized anatomy, particularly its enormous hand claws and powerful forelimbs, suggests it held a distinct niche within the predator guild. While the titanosaurs may have been too large for Megaraptor to tackle alone, the diverse array of smaller dinosaurs and other animals provided ample hunting opportunities. As we reconstruct the ecological relationships within the Portezuelo Formation, it becomes apparent that Megaraptor likely functioned as an apex predator. Its unique adaptations allowed it to exploit prey items that other predators might have found challenging to subdue. This specialization, combined with its considerable size, positioned Megaraptor at the top of the food chain in this ancient Patagonian ecosystem. Megaraptor's role in this complex web of life raises questions about its specific hunting strategies. How did it utilize its unique anatomical features to capture and subdue prey? What were its preferred hunting grounds within this diverse landscape? By examining Megaraptor's paleobiology, we can begin to uncover the secrets of its predatory lifestyle and its influence on late Cretaceous ecosystems in South America. Megaraptor's hunting style was unlike any modern predator, combining unique features that set it apart from other prehistoric carnivores. This late Cretaceous hunter possessed a toolkit that made it a formidable predator in its Patagonian habitat. The hunting behavior of Megaraptor likely involved a combination of stealth and sudden, powerful attacks. Its agility and speed, coupled with the dense vegetation of its environment, would have allowed it to stalk and ambush its prey effectively. Once within striking distance, Megaraptor could have used its specialized adaptations to grapple with its victim, inflicting deep, debilitating wounds. Megaraptor's potential prey included a variety of contemporary dinosaurs. Smaller theropods would have been prime targets, easily overpowered by Megaraptor's superior size and weaponry. More intriguingly, some paleontologists suggest that Megaraptor may have been capable of taking down juvenile titanosaurs. While adult sauropods would have been too large to tackle, younger individuals could have fallen prey to this formidable hunter. As we piece together the evidence, a picture emerges of Megaraptor in action. Imagine this predator moving silently through the Cretaceous forests, its keen senses alert for potential prey. Upon spotting a suitable target, perhaps a smaller theropod or a young sauropod separated from its herd, Megaraptor would spring into action. With a burst of speed, it would close the distance, using its specialized adaptations to subdue its quarry. This highly specialized hunting strategy represents a unique evolutionary path among theropod dinosaurs. While other large predators of the time relied on bone-crushing bites or pack-hunting tactics, Megaraptor developed a more precise approach to taking down its prey. This level of specialization suggests that Megaraptor occupied a distinct niche within its ecosystem, perhaps allowing it to coexist with other large predators by exploiting different prey items or hunting strategies. As we continue to unravel the mysteries of Megaraptor's predatory lifestyle, we gain valuable insights into the diversity of hunting strategies that evolved among theropod dinosaurs. This unique predator serves as a testament to the evolutionary innovations that arose during the late Cretaceous period, challenging our understanding of predator-prey dynamics in prehistoric ecosystems. The study of Megaraptor's hunting behavior not only illuminates its specific adaptations, but also provides a broader perspective on the complex ecological relationships that shaped life during this fascinating period of Earth's history. Megaraptor's true legacy extends beyond its impressive hunting abilities, potentially holding the key to unlocking a major evolutionary puzzle. Recent studies have ignited a debate that could significantly alter our understanding of theropod-dinosaur relationships. While the classification of Megaraptor has been a subject of intense scientific scrutiny since its discovery in 1996, new research continues to challenge existing theories. A 2012 hypothesis proposed by Fernando Novas and colleagues suggests that Megaraptor and its relatives are deeply nested within Coelurosauria, a group that includes modern birds and their closest extinct relatives. This theory places Megaraptor in close relationship with Tyrannosaurids, based on shared anatomical features such as elongated metacarpals and a pneumatic ilium. However, the debate remains far from settled. Some analyses continue to support Megaraptor's original classification as an allosauriod, while others argue for its position as a basal coelurosaur. A 2022 study by Rolando and colleagues added another layer to this complex puzzle, suggesting that Megaraptor might be the sister taxon to Tyrannosauroidea. This finding, if corroborated, could have significant implications for our understanding of theropod evolution and the origins of some of the most iconic predatory dinosaurs. The discovery of Gualicho, a theropod related to Megaraptor, has further complicated matters. This find has raised questions about whether Megaraptorans fit neatly into the Tyrannosauroid category, or if they represent a distinct lineage of basal coelurosaurs or even allosauroids. The placement of Megaraptor and its relatives has become a critical point in broader debates about theropod evolution, with potential ramifications for how we understand the development of key traits in different dinosaur lineages. As paleontologists continue to unravel the mysteries of Megaraptor's evolutionary relationships, we edge closer to a more complete understanding of theropod diversity and the complex evolutionary pathways that led to the incredible variety of predatory dinosaurs in the late Cretaceous period. The impact of these findings extends far beyond Megaraptor itself, potentially reshaping our entire conception of how different groups of theropods are related and how key adaptations evolved over millions of years. The ongoing research into Megaraptor's classification serves as a powerful reminder of the dynamic nature of paleontology. It underscores the challenges scientists face in accurately reconstructing the evolutionary history of long-extinct creatures based on incomplete fossil evidence. As new specimens are discovered and new analytical techniques are developed, our understanding of dinosaur evolution continues to evolve, sometimes in surprising ways. The study of Megaraptor presents a unique challenge in paleontology, akin to assembling an ancient jigsaw puzzle without a reference image. Each new fossil discovery has the potential to dramatically reshape our understanding of this enigmatic predator's anatomy, behavior, and evolutionary relationships. One of the most significant challenges faced by paleontologists studying Megaraptor is the fragmentary nature of its fossil remains. The initial discovery of a single enormous claw led to misclassification and years of debate about its true nature. The revelation that this claw belonged to the hand rather than the foot of Megaraptor was a pivotal moment, forcing a complete reevaluation of its place in the Theropod family tree. The ongoing process of interpreting Megaraptor's fragmentary remains has led to continuous debates about its classification and evolutionary relationships. Paleontologists must meticulously analyze each new fossil, considering how it fits with existing evidence and what it might reveal about Megaraptor's lifestyle and evolutionary history. This process requires constant revision of previous assumptions in light of new data. A particularly notable fossil find was the discovery of a juvenile Megaraptor specimen in 2014. This provided crucial evidence supporting its classification as a primitive tyrannosauroid, showcasing similarities in skull structure to early tyrannosaurids. Such discoveries highlight the importance of finding specimens at different life stages to fully understand a species' development and evolutionary relationships. The challenges of studying Megaraptor extend beyond classification. Paleontologists must also grapple with questions about its behavior, habitat, and role in its ecosystem. With limited fossil evidence, reconstructing these aspects of Megaraptor's life requires careful analysis and often involves drawing comparisons with better-known theropod species. Fernando Novas, a leading researcher in Megaraptor studies, emphasizes the significance of these discoveries in understanding theropod evolution. He states, "Megaraptor is a testament to the incredible diversity of life that existed millions of years ago." His words underscore the importance of continued research in unraveling the complexities of prehistoric ecosystems and evolutionary pathways. As paleontologists continue their work, each new Megaraptor fossil has the potential to provide critical insights. The ongoing nature of this research serves as a powerful reminder of the dynamic and ever-changing landscape of scientific knowledge, particularly in a field as complex as paleontology. The story of Megaraptor remains far from complete, with future discoveries promising to shed more light on this fascinating predator from the distant past. The global distribution of Megaraptor's relatives reveals a fascinating story of prehistoric migration and adaptation. While Megaraptor itself was discovered in South America, its close relatives have been found across multiple continents, including Australia, Asia, and possibly Africa. This widespread presence challenges previous assumptions about dinosaur evolution and migration patterns. In Australia, paleontologists have unearthed Australovenator, the largest known predatory dinosaur from the continent. Sharing anatomical similarities with Megaraptor, such as specialized hand claws and elongated limb bones, Australovenator suggests a close evolutionary relationship between South American and Australian Megaraptorans. This connection hints at shared ancestry or potential migration routes between these now distant landmasses. Asia has also yielded important Megaraptoran fossils, including the genus Fukuiraptor discovered in Japan. Considered a basal member of the Megaraptora clade, Fukuiraptor provides crucial insights into the group's evolutionary history. Its presence in Asia suggests that Megaraptorans may have originated there before dispersing to other continents. The global distribution of Megaraptorans raises intriguing questions about their migration patterns and evolutionary adaptations. A study by Phil Bell and Steve Salisbury proposes that Megaraptorans originated in Asia during the late Jurassic period, diverging in the early Cretaceous. They suggest a subsequent dispersal to South America via Antarctica, which may have acted as a land bridge facilitating faunal exchange between these regions. This paleobiogeographic hypothesis portrays Megaraptorans as highly successful predators, capable of thriving in diverse environments across multiple continents. Their ability to colonize varied habitats demonstrates the group's evolutionary flexibility and the interconnectedness of prehistoric ecosystems. The implications of this global distribution are significant. It forces us to reconsider our understanding of Cretaceous ecosystems and the role these specialized predators played in shaping prehistoric food webs across the globe. As new Megaraptoran fossils continue to be discovered worldwide, our understanding of these fascinating theropods and their place in dinosaur evolution continues to expand. The story of Megaraptor and its relatives serves as a powerful illustration of the dynamic and interconnected nature of prehistoric ecosystems. It challenges us to think on a truly global scale when considering the evolution and distribution of ancient life forms, highlighting the complex interplay between geography, climate, and evolutionary processes that shaped the prehistoric world. Megaraptor's size estimates have evolved significantly as new discoveries have refined our understanding of this enigmatic predator. While earlier estimates suggested lengths of up to 10 meters and weights around 2 tons, recent research has provided more nuanced figures. The discovery of Mape macrothorax, currently considered the largest known Megaraptoran, has offered valuable insights into the potential size range of this group. Mape is estimated to have measured up to 9 meters in length, indicating that the upper size limits for Megaraptorans might be slightly lower than some earlier projections for Megaraptor itself. These refined estimates carry significant implications for our understanding of Megaraptor's ecological role. Its dimensions, combined with its unique anatomical features, provide crucial insights into its predatory capabilities. The robust build, elongated claws, and powerful forelimbs of Megaraptor suggest it was well adapted for taking down large prey. This combination of size and specialized hunting adaptations indicates that Megaraptor likely occupied a distinct niche in its ecosystem, perhaps capable of targeting prey that other large theropods found challenging. The ongoing refinement of Megaraptor's size estimates contributes to a clearer picture of its place in the late Cretaceous food web. By comparing Megaraptor's dimensions to those of its contemporaries, such as Giganotosaurus and Carcharodontosaurus, researchers can better understand the competitive dynamics and predator-prey relationships of the time. This information is crucial for reconstructing the complex ecosystems of the late Cretaceous period. Furthermore, the revised size estimates for Megaraptor highlight the importance of continuous research and the impact of new discoveries in paleontology. Each new fossil find has the potential to alter our understanding of prehistoric life, demonstrating the dynamic nature of this field of study. As we continue to unearth more evidence, our knowledge of Megaraptor and its relatives will undoubtedly become more precise, allowing for increasingly accurate reconstructions of these fascinating creatures and their world. While Megaraptor's giant claw was undoubtedly an impressive sight, recent biomechanical studies have revealed its true significance as a multifunctional tool crucial for survival and hunting. The claw's unique structure, featuring asymmetrically positioned grooves and a sharp ridge, allowed for both slashing and gripping capabilities. This specialization set Megaraptor apart from its theropod contemporaries, enabling it to inflict deep wounds while maintaining a secure hold on prey. Paleontologists have proposed that Megaraptor used its elongated arms and massive claws to grapple with victims, holding them in place while delivering fatal bites. This strategy would have been particularly effective against large prey, potentially including juvenile sauropods, which other predators might have struggled to subdue. The extreme curvature of Megaraptor's claws, even more pronounced than those of Spinosaurids, indicates a highly specialized gripping function. This feature, combined with the claw's length and sharpness, made it an exceptionally effective tool for latching onto and subduing prey. Biomechanical analyses have shown that Megaraptor's forelimbs were remarkably well developed, allowing for complex movements such as great extension and flexion. This capability suggests that the arms and claws were integral to its hunting technique, enabling the predator to reach out, grab prey, and maintain a grip while delivering killing bites. While hunting was likely the primary function of Megaraptor's claws, they may have served additional purposes. These formidable weapons could have been used in intraspecific combat for territory or mating rights. Some paleontologists have even speculated about their potential role in object manipulation or climbing, although the latter remains conjectural given Megaraptor's large size. The specialized nature of Megaraptor's claws allowed it to occupy a unique niche in its ecosystem, potentially exploiting prey items that other predators found challenging to subdue. This adaptation highlights the diversity of predatory strategies that evolved among theropod dinosaurs during the late Cretaceous period, showcasing nature's capacity for producing highly specialized anatomical features to fill specific ecological roles. Reconstructing the appearance of extinct animals like Megaraptor is a complex process that combines scientific analysis with informed speculation. While early depictions portrayed Megaraptor as a giant dromaeosaurid with a sickle-shaped foot claw, new fossil evidence has dramatically reshaped our understanding of this prehistoric predator. Recent advancements in reconstruction techniques have allowed paleontologists to glean more information from fossilized remains. For example, analysis of bone histology reveals growth patterns and potential skin coverings, while the orientation of blood vessel channels in bones offers clues about skin texture. These methods have contributed to a more accurate representation of Megaraptor's appearance. Paleoartists like John Conway and Julius Xottoni have played a crucial role in visualizing Megaraptor based on the latest scientific findings. Their work involves not just artistic skill, but also a deep understanding of anatomy, biomechanics, and paleontology. Conway notes, each new fossil discovery has the potential to dramatically alter our understanding of how these animals looked and behaved. Current reconstructions of Megaraptor present a large, agile predator with powerful forelimbs and enormous hand claws. Its body is likely covered in a combination of scales and primitive feathers, a far cry from the oversized raptor initially imagined. The elongated skull and relatively lightweight build suggest a swift, precise hunter rather than a lumbering brute. One recent artistic change involves the depiction of Megaraptor's feather covering. New evidence suggests that its feathers may have been more extensive than previously thought, potentially covering larger portions of its body. This has led to updated artwork showing Megaraptor with a fluffier appearance, particularly along its back and tail. Another area of focus in recent reconstructions is the precise arrangement and function of Megaraptor's famous hand claws. Paleontologists have been studying the biomechanics of these claws, leading to more accurate depictions of how they were likely used in hunting and feeding behaviors. As paleontologists continue to unearth new Megaraptor fossils and refine their analyses, our vision of this fascinating predator continues to evolve. Each discovery has the potential to reveal new aspects of Megaraptor's appearance and behavior, prompting further revisions to its reconstructions. This ongoing process not only enhances our understanding of Megaraptor, but also serves as a powerful reminder of the dynamic nature of scientific knowledge in paleontology. Megaraptor's portrayal in popular culture reveals an intriguing gap between scientific understanding and public perception. This late Cretaceous hunter has captured the imagination of audiences worldwide, often appearing in media with dramatic embellishments that stray from paleontological evidence. Documentaries have introduced Megaraptor to the general public, but sometimes prioritize dramatic effect over scientific accuracy. For instance, the series When Dinosaurs Ruled featured Megaraptor as a formidable predator, sparking interest in paleontology while potentially leading to misconceptions about its true nature and capabilities. In video games, Megaraptor has become a fearsome adversary, with developers exaggerating its size and ferocity for more challenging gameplay. While entertaining, these portrayals diverge significantly from current scientific understanding, reinforcing inaccurate ideas about Megaraptor's role in prehistoric ecosystems. The impact of these representations on public understanding is significant. Media portrayals have increased interest in prehistoric life, inspiring new generations of paleontologists and dinosaur enthusiasts. However, the discrepancies between dramatized versions and scientific evidence can lead to persistent misconceptions about Megaraptor. As new discoveries refine our understanding of Megaraptor, the challenge lies in bridging the gap between scientific knowledge and public perception. Accurate science communication plays a crucial role in this process. Paleontologists and science communicators must present the latest research findings in engaging ways that can compete with sensationalized media portrayals. Megaraptor's popularity presents a unique opportunity to showcase the dynamic nature of paleontological research. By highlighting how our understanding of Megaraptor has evolved over time, educators can illustrate the scientific process in action, fostering a deeper appreciation for the complexities of studying prehistoric life. In this way, Megaraptor serves as a bridge between academic paleontology and public interest in dinosaurs. Its story demonstrates how scientific knowledge is continually refined and updated, challenging us to question our assumptions and remain open to new discoveries. As research into Megaraptor and its relatives continues, we can anticipate further revelations that may once again transform our understanding of this fascinating predator, keeping both scientists and the public eagerly awaiting the next chapter in its evolutionary tale. While significant progress has been made in understanding Megaraptor, several unique questions continue to challenge paleontologists. The true phylogenetic position of this enigmatic predator remains a subject of debate. Initially classified as a giant dromaeosaurid, subsequent discoveries have led to multiple reclassifications. Some studies suggest a close relationship with tyrannosauroids, while others place Megaraptor among more basal theropods. This uncertainty stems from the unique combination of features found in Megaraptor's anatomy. Paleontologists are particularly interested in uncovering more complete skull material, which could provide crucial insights into Megaraptor's sensory capabilities and feeding habits. The exact hunting strategies and prey preferences of Megaraptor also remain subjects of inquiry. While its large hand claws suggest a unique predatory approach, the specifics of how Megaraptor captured and subdued its prey are still speculative. Future discoveries of more complete specimens or trace fossils, such as bite marks on prey bones, could help clarify these aspects of Megaraptor's behavior. To address these questions, researchers are employing various approaches. Advanced imaging techniques are being applied to existing fossils, potentially revealing previously unseen details in bone structure and muscle attachments. These methods may provide new insights into Megaraptor's anatomy and locomotion without the need for additional specimens. Paleontologists are also focusing on comparative studies with other theropods to better understand Megaraptor's evolutionary relationships. By analyzing subtle differences in bone structure and comparing them to well-understood theropod lineages, researchers hope to refine Megaraptor's position in the dinosaur family tree. The study of Megaraptor continues to drive innovation in paleontological methods and theories. From advanced phylogenetic analyses to cutting-edge fossil preparation techniques, each new discovery has the potential to reshape our understanding of this fascinating predator and its role in late Cretaceous ecosystems. Megaraptor's discovery in 1996 marked a turning point in paleontology, reshaping our understanding of theropod dinosaurs and driving significant advancements in research methods. As scientists grappled with this enigmatic predator's unique features, they developed innovative techniques for analyzing fragmentary fossils and refining phylogenetic analyses. These new approaches have since been applied to other prehistoric species, enhancing our ability to reconstruct ancient ecosystems and evolutionary relationships. The challenges posed by Megaraptor's distinctive anatomy spurred breakthroughs in biomechanical studies. Researchers developed sophisticated computer models and simulation techniques to better understand how these ancient predators moved and hunted. These advancements have not only illuminated Megaraptor's behavior, but also provided valuable tools for studying other extinct species. Megaraptor's impact extends beyond methodological innovations. Its existence has prompted a re-evaluation of theropod diversity and adaptations, showcasing nature's capacity for producing specialized predators. This has led to a broader shift in scientific perspectives, encouraging paleontologists to question long-held assumptions about dinosaur evolution and consider a wider range of possibilities when interpreting fossil evidence. The ongoing debates surrounding Megaraptor's classification have highlighted the complexity of evolutionary relationships and the challenges of reconstructing prehistoric life. This has fostered a more nuanced approach to paleoecology, emphasizing the importance of considering multiple lines of evidence and remaining open to unexpected discoveries. Megaraptor's legacy has also influenced how paleontologists communicate their findings to the public. The dramatic revelations about its unique features have captured public imagination, demonstrating the power of unexpected discoveries to engage people with science. This has encouraged researchers to find new ways of sharing their work, fostering greater public understanding and support for paleontological research. As studies of Megaraptor and its relatives continue, the field of theropod paleontology remains dynamic and exciting. Each new discovery has the potential to further refine our understanding of these fascinating creatures and their place in prehistoric ecosystems. The ongoing research into Megaraptor serves as a reminder that our knowledge of prehistoric life is constantly evolving, driven by new evidence and innovative analytical techniques. Megaraptor stands as a testament to the transformative power of paleontological research. Its impact extends far beyond a single species, influencing methodologies, perspectives, and public engagement across the field. As we look to the future, the story of Megaraptor and its profound effect on our understanding of dinosaur evolution continues to unfold, promising further insights into the rich tapestry of prehistoric life. Megaraptor stands as a testament to the ever-evolving nature of paleontological discovery. This enigmatic predator has repeatedly challenged our assumptions about theropod evolution, forcing scientists to reevaluate long-held theories. From its initial misclassification to the ongoing debates about its true phylogenetic position, Megaraptor exemplifies how new fossil finds can dramatically reshape our understanding of prehistoric life. The story of Megaraptor underscores the critical importance of continued fossil research. Each new discovery has the potential to unveil previously unknown aspects of dinosaur anatomy, behavior, and ecology. As paleontologists continue to unearth and analyze Megaraptor remains, they not only shed light on this fascinating creature, but also refine our broader understanding of Cretaceous ecosystems and theropod diversity. Looking ahead, the field of paleontology holds the promise of further transformative discoveries. Future finds may reveal new Megaraptor species, uncover more complete specimens, or provide insights into its hunting strategies and prey preferences. These potential discoveries remind us that our knowledge of prehistoric life is far from complete, and that the ancient world still holds many secrets waiting to be unearthed.